Let's give this definite integral a try. It looks kind of challenging, so what I'm going to do first is go ahead and just try to rewrite this. So we still have the integral from 4 to 8, but because we're dividing by a monomial, what I'm going to do is take one copy of that and put it with each term from the numerator. So I'm going to rewrite it also as x to the 1/2 power with a rational exponent as opposed to having a square root over top. All right, from here, let's go ahead and do a little bit of simplifying down. We can simplify this by going ahead and combining. We have x's in the numerator and in the denominator. So let's go ahead and say that's 4x to the 2 minus a half makes 3/2 plus 5. And then we can rewrite this with a negative exponent. That's going to make life easier on us as we're trying to integrate. We can use our power rule at this point. So we'll bring the 4 along. We're going to increase the exponent by 1 using the power rule. So 3/2 plus 1 is the same thing as 3/2 plus 2/2, which makes 5/2. Now normally we divide by our new exponent, but because it's a rational exponent, I'm going to multiply by its reciprocal instead. Then we're going to bring along that next term. We bring the 5 along. We increase the exponent by 1. So negative 1/2 plus 1 makes positive 1/2. And again, I'm going to multiply by the reciprocal, which is 2 over 1. Now all of this still needs to be evaluated between 4 and 8. And as I do this, I'm going to go ahead and clean this up and make this 8/5 x to the 5/2 plus 10 x to the 1/2, evaluated between 4 and 8. Now's the point where I'm going to actually go ahead and evaluate putting the upper bound of integration in first, so 5/8, and then 8 to the 5/2 power, plus 10 times 8 to the 1/2 power. And then we subtract away, big set of parentheses because it's all supposed to be subtracted, 8/5, 4 to the 5/2 power, plus 10 times 4 to the 1/2 power. Now, 4 to the 5/2 will work out pretty nicely, and 4 to the 1/2 will work out very nicely because that means the same thing as the square root of 4 here. 8 to the 5/2 and 8 to the 1/2 will not work out very nicely. So what I'm going to do next is just go ahead and put this in my calculator and get a decimal approximation to go along with it. So it is approximately this. I'm not giving an exact answer. It's going to work out to be 246.7152 ... continues on, presumably forever, irrational. All right, so I hope this helps out as you're working on what works out to be a kind of complicated looking problem, but you can get there as long as you follow your mathematical exponent rules. Good luck.